Welcome to the Explainer. So today we're going to pull back the curtain on something we all use every single day, but almost never think about: the internet's invisible foundation. We're going to uncover the hidden mechanics that let your computer send a simple hello and boom, in a split second, get a hello back from literally anywhere on the planet. It really does feel like magic, right? You hit a button and information just appears instantly. But it's not magic. It's actually this beautifully engineered dance between computers, and it's all governed by a really precise set of rules. So let's dive in and explore that dance together. So, how do computers actually talk to each other? Well, for any two computers to exchange data, and it doesn't matter if they're in the same room or on different continents, they need two things: a shared language and a set of rules. And in the networking world, we call that combination a protocol. All right, let's talk about the rules of the road. How do we even begin to make sense of all these protocols? Well, to understand how they all work together, network engineers came up with these layered models. You can think of them as a kind of blueprint. They take this super complex process of communication and just break it down into smaller, much more manageable steps. Okay, so here you're looking at the two most common models, OSI and TCP/IP. The best way to think about them is like a stack of responsibilities. Down at the very bottom, you've got the physical layer. That's the actual hardware. We're talking cables, radio waves, the real nuts and bolts. Then, way up at the top, you have the application layer. That's the software you're actually using, like your web browser. So for any message to get sent, it has to travel all the way down this stack on the sender's computer, getting prepped at each level, and then it goes all the way back up the stack on the receiver's end to be understood. So what's actually happening as your data travels down through all those layers we just saw? Well, each layer adds its own little bit of information. Think of it like an address label or special handling instructions. And this whole process of wrapping the data in these protective layers of info, it's called encapsulation. And you know what? The source material for this explainer gives us the perfect analogy for this. A matryoshka doll, those Russian nesting dolls. Just picture it. Your actual data, your hello message, is the tiniest little doll right in the center. Then each layer of the protocol stack puts that doll inside a slightly bigger one, adding its own information on the outside until it's ready to be sent over the network as one big, fully packaged doll. It's a really fantastic way to visualize what encapsulation is all about. Okay, so our data is all perfectly packaged up, but how does it know where to go? I mean, it needs directions, right? That is where routing comes in. It's basically the internet's GPS. Routing is the whole process of finding the most efficient path for your data packets to travel from you to their destination, and it has to navigate across literally thousands of interconnected networks to do it. So this is all great in theory, but let's make it real. Let's actually see it happen. We're going to trace the journey of a simple hello message using a standard tool called the TCP echo service. And the name pretty much gives it away. Whatever you send to the server, it just echoes it right back to you. It's the perfect, simple way to see all these concepts in action. And here's what that actually looks like in practice. Now, don't worry about trying to understand every single line of code on the screen. The key takeaway is right there in the highlighted lines. You can see the server is waiting, and then, bam, it says received hello from client. It immediately follows that up with sent hello to client, and then the connection closes. That's it. This super simple exchange is the basis for our entire hello and hello back journey. But wait a second. Hold on. Before that hello message could even be sent, the two computers had to, formally introduce themselves and agree to talk in the first place. For reliable protocols like TCP, every single conversation has to begin with this special greeting. It's called the three-way handshake. So this diagram here shows you the entire life cycle of that conversation, but from the software's point of view. You've got the client down at the bottom and the server up top. And I want you to notice something really important. Before any data is actually sent or received, there's this crucial first step. The client initiates a connect, and the server has to accept. That right there, that initial agreement, that's the handshake in action. Okay, step one. It all begins with the client. It sends out a special little packet with a SYN flag, which is just short for synchronize. You can think of this as the client basically knocking on the server's door and asking, "Hey, are you there? I'd like to start a conversation." All right, on to step two. Assuming the server is available and listening, it responds. It sends back its own special packet that actually has two flags set, SYN, because it also wants to synchronize, and ACK, which stands for acknowledge. This is the server basically replying, "Hey there, client. Yep, I'm here. I got your message, and I'm ready to talk too." And finally, to complete the handshake, we have step three. The client sends one last packet back. This one just has the ACK flag set, and this is the client confirming, "Awesome, I got your response, we're good to go, the connection is established." And it's only now, after this three-part agreement is complete, that our hello message can finally be sent. So let's just recap that super important three-step process real quick. The client sends a SYN, the server replies with a SYN at an ACK, and the client confirms with a final ACK. That's it. This simple but really robust exchange makes sure that both sides are ready and able to communicate before any actual data gets transmitted. This is the absolute foundation of a reliable connection. Okay, great. So we've got a reliable connection, but is it private? I mean, can somebody else listen in on our conversation? By default, the answer is a big, fat yes. That initial TCP handshake, it establishes a connection, for sure, but it provides zero security. To fix that, we need to add another layer on top, a layer of trust. And this is where something called Transport Layer Security, or TLS, comes into play. You might actually know it by its older name, SSL. TLS is a protocol that runs right on top of TCP, and it basically wraps our entire conversation in this protective layer of really strong cryptography. This does two critical things. It ensures privacy, so nobody can eavesdrop, and it ensures integrity, which means the message can't be messed with along the way. Now, a really key part of TLS is authentication. The server has to prove it is who it says it is, and it does this using something that's basically a digital ID card. It's called an X.509 certificate. This certificate gets issued by a trusted authority, and it confirms that you're really talking to, say, Google.com, and not some imposter who's trying to intercept your data. Honestly, the difference this makes is just night and day. An unencrypted connection, that's like sending a postcard. Anybody along the delivery route can just pick it up and read the whole thing. But a TLS-secured connection, well, that's like putting your message inside a sealed, tamper-proof envelope. Only the person it's addressed to has the key to open it and see what's inside. And that's it. That's the invisible foundation. Understanding these layers, these handshakes, and these security protocols is so critical because literally every website you visit, every app on your phone, every single online service you use is built on top of these fundamental principles. They are the absolute bedrock of our digital world. So now that you know how the road is built, what can you build on top of it?